good morning, good afternoon. I am Daniele from LearnCube, and we are ready, I guess, to start the stream. Let me just check on LinkedIn how you're doing. Yeah, we should be all right. Yes. Yes, it's all working now. Thank you. Cool. I've got Rafa with me today. Thank you very much for joining, Rafa. We already had chat about what is the plan for KubeCon, when we're gonna go, how far is it, and it's pretty far for me, but we'll see. We'll see about that. But okay, today, what I wanted to talk about today. So the plan for today is we're gonna go and explore how the Kubernetes API works. So I will cover that, and then I'm gonna pass on to Rafa. And we're going to explore a little bit of server-side applied. I think the part of server-side applied is quite interesting because we're going to understand how some of the fields that we use in the YAML are going to be used by humans and machines together, which is, I think in a way it is somewhat unusual because we just, most of the time we think we just do a kubectl apply and everything is going to work fine. But what if you have Argo and you want to do kubectl apply? How does that work? So I think Rafa will explain about that. Yes, Rafa, do you anything you want to say before we start with the stream?
Just thank you, Dan. Thank you, KubeFM, LearnCube, all the affiliated conglomerate of Kubernetes to the opportunity. And we were chatting before going live, and it feels like we just can continue chatting, about things about life in Kubernetes, and server-side apply is one of the things that came across my life.
Yeah, and we're gonna see how I think there is also a background story on how that was applied to Flux as well, which I think maybe we can share with the audience a little bit later on as well. Cool, thank you, Rafa. So I'm just gonna hide you. I'm gonna share my screen, and I'm gonna take it from there. And then I'm gonna introduce you again. So let me just do that. I'm gonna share my screen so you can see my slides. And then we're gonna start. Okay, ready to start. So my name is Daniele. Dan, you can call me whatever you want. D5E is what Chris, my colleague, calls me because I'm so much into Kubernetes. I've been lucky enough to speak at KubeCon a few times now, and I was one of the first 500 engineers to complete the CKA back in 2017. So I've done quite a fair amount of Kubernetes since then. I usually teach Kubernetes. That's my day-to-day job. And today I will be talking about the Kubernetes API servers and how this API server works and what are the components and how we use it. So without further ado, so the way we start is and we explore this is we look at how we make requests to the Kubernetes API. And the way it works usually is you have a kubectl, a kubectl command line installed locally, and you submit some YAML files to the server. And then that will basically send these requests to the control plane. Inside the control plane, we find the first component that we find is this Kubernetes API server. Now, we usually picture these API servers as a single block, and this single block eventually, when it's done processing these requests, will save our objects into the database, which is etcd. Now, what we need to understand about these API servers is, first of all of these, and it's an API server in the same way you would build an HTTP API server for your own application. So it has API and paths in the same way. The only sort of difference is that it sort of has groups for APIs, and that it has versions and resources. And this might not be totally surprising to you, because this is also exactly what we see in the YAML that we construct when we want to deploy a particular application. So in essence so the API server is a collection of API, a CRUD of API to manage objects, and these paths and versions are also saved in the YAML that you craft. So this API block that we described is basically like, usually we picture it as a big block, but in reality, the way it works is divided into different phases and different blocks. And the first block that we find when we get a request inside the Kubernetes API service is the authentication block. So the authentication block, what it will do, it will basically look at the request and say, okay, is this user allowed to access the cluster? And if it is not, it will give back a 401. If it is, and then it's going to decorate the request with some extra info and then pass it on to the next module. What happens in this decoration? Why do we need this decoration tool? The problem that we are trying to solve here is that usually we have two types of users that are consuming resources in the cluster. The first are normal users like humans, and then the other one is machines, which are service accounts. So for humans, Kubernetes doesn't have a way to model humans in etcd, in the database. So what happens is it basically delegates all of these access to a third-party system. So when a request comes in, what happens is Kubernetes will go and check somewhere else, like an LDAP. It will go and check, who is this user and what kind of access does it, and what kind of, see what kind of profile does it have? Is it valid, invalid? And it will give it back. So it does not model that. It's not modeled inside Kubernetes. It's actually relying on a third-party system to work. Once we have the response back, then Kubernetes will use that inside the authentication to decide how to pass this on or to reject the request. Service accounts, instead, are used for bots, so for machines. And those, contrary to what we see with humans, are actually modeled inside Kubernetes. So service accounts are the object that you create inside Kubernetes to assign identities to things like a controller or a simple script which is going to access the Kubernetes API. And they are very simple. You can see here I've got a very simple service account. And yeah, basically just a way to assign an identity, no more than that. So just give a name to something. Now, service accounts usually, but not always, come with a token assigned, a secret with a token, and that token is basically what you need to call the API and authorize yourself. So that's basically how it works. So when I've got this token, I can use to go and check my credentials and then proceed in the pipeline for the Kubernetes API service. So this is what a service account looks like. So it's very much just a name for something. And the way it works is you've got Kubernetes, the authentication, and then the authentication goes through two phases, the normal users, and the service account. So for normal users, what happens is we have different ways to authenticate humans or just users of the clusters. The first one is a static token file where we just have a static list of tokens. Then we've got certificates, OpenID, authenticating proxy, a webhook. So these are basically all mechanisms that we use to call external services and get an idea of if this user is allowed to enter the cluster or not. Then we've got service accounts and bootstrap tokens. Those are generally used for machines. So this series of plugins that are used to authenticate requests are executed in sequence. And if one succeeds, then you can pass on to the next part. And the next part is usually authorization. So at the end of this phase, you're authenticated. So it means you have access to the cluster, but we are not entirely sure what kind of resources you can access. So you are allowed to enter, but maybe you're not allowed to touch anything, or maybe you're allowed to touch something. We don't know yet. So the next part is authorization. And that's basically divided into, again, there are 4 different ways to authorize your request. So you might be familiar with the most famous ones, which is RBAC, but there is also another one called webhook, where we call an external service, and that's basically an example of this is Azure RBAC, where you can actually integrate your Kubernetes cluster with the existing Azure RBAC permissions that you have in your Azure account. So how does this role-based access control work? So generally, the way it works is we have identities, like a particular controller, and then what we have is basically roles. A controller or a human, we have roles, and roles basically define a set of permissions, so things you can do, and API you can access. And the way we link these roles to identities is we use cluster role or role bindings. So you can imagine that you have like, you define roles as a set of rules. So basically you define, okay, this role is an admin role and has access to everything. This role is a read only on the dev namespace. And this role is, I don't know, write and read, but just on pods. So those are basically like the roles. You define a set of rules that are basically grouped together. And then you have a list of users, which could be humans or service accounts. And you say, okay, this team, from this particular organization, then is going to be only read and write on this particular namespace. To make this link, then you create this role binding or a cluster role binding. So the difference between a cluster role binding and role binding, we're going to have a look in a second. But the idea is that some roles apply to the entire cluster, whereas some roles are just scoped to a namespace. So we need to differentiate those. So let's have a look how it works. So the important thing to remember here is that you have these roles or cluster roles, and they are a group of rules. And then if you look closely, you will notice that these rules are basically just ways to access particular resources on the API. So if I look at this rule, for example, is saying I can get, watch, and list pods. And if I look at the other one, is basically saying, okay, I can only update and patch deployments. So this is basically just rules are ways to grant access to a particular set of APIs in the Kubernetes API server. Now, to link those rules and to a user, we use a role binding or cluster role binding. So the difference is that I need a namespace for a role binding, whereas I need if I use a cluster role binding, that applies to the entire cluster. So the way it works is basically first I define the subjects. So who does this binding apply to? In this particular case, is a human, right? Is a user in my cluster, and I've got a name for it, and then I'm going to reference one role, and that this will basically create a link between the two. That's how we grant access to our cluster. Cool. So now we finished the phase where we know you can enter the cluster, and then we know you have some permissions to list or delete or edit some of the resources in the cluster. What happens next? So it turns out that the next big block inside the API server is admission controllers. And admission controllers actually is broken down even further. And what we have is first mutating admission controllers, and then we've got some schema validation, and then we go through another set of admission controllers, but this time they are validating. So how does this work, and why do we need them? So the first block is mutation admission controllers, and if you look at a regular pod, like in this case, I don't know if you ever tried, but you submit like a regular pod in the cluster. It goes through the mutating admission controller, and if you try to retrieve this YAML from the cluster, then you will notice that some things are being automatically added for you. Like, for example, you might notice that there is an image pool policy of always, but you did not write that to begin with. It turns out that these mutation admission controller are basically ways to modify the request on the fly before it is stored inside the database. And one of the default rules, for example, is this image pool policy. So when the request goes through, if it doesn't have an image pool policy, then the mutating admission controller will inject this on the fly. And this admission controller will not just inject the always image pool policy always, we also inject things such as default ingress class. So if you have an ingress and you don't define an ingress class, then the default ingress class will be automatically injected. Same for storage classes, for tolerations, and there are a number of things that will be basically injected by default. And then on top of that, there are also ways to extend it. But let's have a look at the result of just passing this YAML, simple YAML through a mutation admission controller. This this is what you get at the end, right? So you get a lot of extra sort of info about a pod, a lot of extra fields that you didn't add. So some of these fields are automatically injected by the mutation admission controller. Now, after you mutate it, the next step is basically the schema validation, but the next real step you're interested in is validation admission controller. So validation admission controller is very similar to the mutating one, but the idea here is that we receive the YAML and then we want to do some checks before we actually store this object in the database. And a validation admission controller will check things such as, is this pod allowed to be deployed in the cluster in the namespace because maybe the namespace doesn't exist. How do we stop that? Well, it is actually stopped here at this layer in the validation admission controller. Another good example is there enough quota to run this pod in a namespace? Actually, the check is done inside here, inside the validation admission controller. So we check if there is, you have enough memory in CPU, or the count of pods is not exceeding what you define in the quota. So all of these sort of checks are done here, and if for some reason the check fails, then this pod will not be written inside the database. If it is, we will serialize. If it is not, the request will be rejected back. Now, there are two special things in this mutating and validating admission webhooks. And those are the two hooks that you can have, which are basically called as part of a sequence for the mutating and validating admission for the admission controllers. And what does it mean? It means that as you go through the checks, you can actually call an external service to do the mutation, or an external service to do the validation. And this is quite convenient because you can sort of build your own ways to modify YAML resources, or your own way to validate these YAML resources are actually compliant. And compliant could mean different things for different companies and different people, but the idea here is that you could potentially add labels and annotation on the fly. You could inject sidecars, for example, which is what we do when we install something like Istio or a service mesh. Most companies also have policies for installing images which are only originating from their own container registry, right? They don't want to pull from Docker Hub, for example. Well, you can do that. You can do the inspection and validation at the validating admission controller. So that's a good way, a good example of what is allowed and what is not allowed, but it's a custom rule that you have inside your company. And then you can restrict insecure configurations, such as don't want privilege pods or anything like that. So all of these checks can be done inside the validating admission controller. Cool, a good example of that. So let's have a look at some examples. If I want to restrict the registry where this comes from, I can basically just have a policy for that. I can restrict what can be done with the security context. I can inject sidecars. So those are all good examples of what these webhooks are capable of. Another one is I can basically validate that the host for the ingress is always correct and it's not just something random or different from what I'm allowed to use. So all of these checks can be done in that layer. So some popular tools for these kind of checks are Kyverno or the Open Policy Agent, Gatekeeper, Kubewarden. Back in the days, we used to have JSON policies, a bunch of of them, but those are like primarily the options. Cool. Now we're done. We modified it, YAML, we validated it worked. So the only thing left to do is to basically serialize the request and persist that request in etcd. That's the end of basically of this request. At the end of this, we'll save the object. Now we talked about the API server. We briefly said, the request comes in from kubectl. Well, there is something else you need to know about kubectl. So first of all, kubectl, it's not just curl. It's not just like send the YAML, done. Actually, kubectl is a quite complex piece of engineering. And first of all, when you actually submit a YAML resource through kubectl, kubectl will basically validate this resource client-side. And if there are not enough information, it can also run extra code to actually generate the YAML for you. And that's when you use kubectl run, for example. And it will basically construct this in-memory object before it sends it to the API. But how does kubectl know that some YAML is valid or not? Well, it turns out that kubectl will basically just interact with the cluster, will basically just interact with the Kubernetes API server, will return back all the specs for all the resources via the Open API. So basically, kubectl will query the Open API, so this will basically download all the schema locally. So when you submit a YAML, you can do the validation locally rather than on the cluster, and then it gets submitted. And that's cool, basically. And then on top of that, we also have API negotiation, where basically kubectl can see that there are different versions of the pod and different versions of the resource, and can negotiate the right resource for the cluster. Cool. The other things which I want to mention is that sometimes you do have some YAML, and then you have a version, for example, for the image, but it's actually not used by you, right? It's actually, you set it, and then you have like an external system which edits those values for you on your behalf. And kubectl, you can always go in and then edit that value in the YAML. But here is the problem. Should kubectl actually change that value, which was amended by an external controller, or should that value stay the same? So should kubectl allow you to do that, or should the Kube API server reject that idea and say, no, someone else edited this value? Well, it turns out that this is a hard problem, and then hopefully Rafa is going to show why it is a hard problem and why we should fix this. So let me just okay, Rafa, it's your turn now. Let me figure out how to stop Echo. There we go. I'm done. Stop sharing. I'm gonna go in the background.
Okay, let me go ahead and share my screen.
Okay.
I'm gonna share my entire screen. I have nothing to lose in this live. Okay. Guys can see it?
Yes, I'm gonna go on mute. I'm looking forward to this.
All right, cool. All right, let me put in slideshow. My name is Rafa. I have a slide about myself. We're gonna talk about Kubernetes server-side apply. I'll try to insert this in on the first part of this training. Yofty helped me to produce this material, and we try to put some light on the very niche, if not say obscure part of Kubernetes. All right, first, an intro about myself. There's a QR code of my LinkedIn. More than happy to connect. I'm old. I started my career in the 90s with Novell Nature and then Unix. Every time I go to talks on KCD, I always start with this, and always someone like yell Novell or HPUX. You can hear by my accent. I'm Brazilian, born and raised in Rio, live in New York for many years. Now I live in Austin, Texas. First Kubernetes in production was 2016. Can you believe that? I was the container global engineer lead for Citigroup. Then I went to VMware. I left Citigroup with this quest to make Kubernetes easier for enterprise. I went to VMware. I have a patent and a Kubernetes migrator to move Kubernetes workloads across cloud providers. And now I work for Stormforge Cloudboat, and we do optimization of Kubernetes at scale using machine learning. And I wrote controllers and other stuff that they're gonna touch a little bit during this presentation. Very involved with the community, CNCF ambassador, CNCF tag operational resilience co-chair for 1 year. I lead the Austin community group. So if you're based in Austin, based in Central Texas, reach out to me. You should come once a month. We have amazing talks, and we are cooking KCD Texas next year, and I organized KCD Brazil this year as well. Finally, co-author acing the CKA with my good friend Chad Crow. He wrote the first edition, and I helped the second edition. And knock on wood, to be released at KubeCon North America in 3 weeks. We are on target. So, right, let's talk about server-side apply. I hope to make simple, and it took me many ways to go to there to make it simple. And first we start what is the problem, right? It's part of life with Kubernetes nowadays, becoming very complex and long. And we have multiple actors touching a single manifest. Like what kind of actors are we talking about? Argo, Helm, HBA, other controllers, and each one want to touch just one part of the manifest. The HBA want to change the replicas. A resource management controller like us will just change the resources. And every time that you do this, try to change the whole monolithic YAML, it causes conflicts and data loss, because who is the last one to write the whole thing? Solution, server-side apply, introduced in 118 and GA 122, has been so long, 4 years. And why still something that we don't talk every day? Very well. In the beginning of Kubernetes, as I mentioned before, we have this long ass YAML on Git or your kubectl, and you go ahead and do a kubectl apply, and the manifest on the cluster will match what you have on Git. Will match what you have in a local directory and so on. That was in the beginning. But what's happening behind the scenes, right? In the middle, have, for example, deployment. You have so many components changing that deployment. The Kubernetes API itself defaults a bunch of fields. If you have GitOps, you initialize that object and syncs this object to enforce what we want to control. The controller of the deployment right here will reconcile the spec and writes on the status. Yeah, the controller writes the object on the status. If you have HPA just gonna change one field of the entire YAML. If you have a resource controller that will patch your resources, your requests and limits, you will just change that bit. If you have a networking controller, you mutate and so on. This graphic, just want to give the prop, was inspired by a talk by Protosowski from KubeCon North America 2023. And what we have today, because we have multiple actors, Git perhaps no longer the source, the single source of truth. For example, the replicas might not be one anymore. Same thing with requests, because you have different controllers. So if you go to the cluster and you do a kubectl get, you might see replicas 8. You might see different settings for CPU and limits. And what's the solution for it, for all those actors? We have manage fields. Every object since 118 and 122 GA has managed fields under metadata. Server-side apply track all the changes of every field under it. If two actors try to change the same, it will raise a conflict. It's going to give them HTTP 409 and stop. And we're going to talk a little bit how we can configure to avoid this. Some of the logic that Dan spoke about client side now moved from the kubectl into the API. So now the API will be in charge to do the merge. And because the API does this, it's much more, is a central location and is consistent. Okay, let's talk about managed fields, which is the workhorse of this solution. So every change on the Kubernetes object, it's on .metadata.manage fields. If you do a kubectl get, it will not show that. It used to. I remember when that was introduced, it caused a lot of noise, a lot of output, people complaining. So by default, you don't see the managed fields. If you want to see the managed fields, you need to put -- show managed fields. And I'm giving here a easy way to just filter that using YQ. The YQ.metadata.manage fields. And you're going to see a list. It is a slice of changes of your object. In this screenshot, I'm just giving one entry, but you can have so many, depending on the number of actors changing your object. I'm giving here when StormForge, my company, applies a patch to manage just the field of resources, in this case, requests, and put in some annotations. So every record of the managed fields, you have fields, which fields I own, who owns the manager, what kind of operation apply or update, and a timestamp. I'm putting some errors here in case you do not get confused. So I invite you to go to any object of your cluster and do this and inspect. Pick one that multiple changes happening, you see. So SSA, besides introducing the managed fields, it introduced a new type patch. And I'm putting here the screenshot of the actual code of Kubernetes 134. The first 3 patches, we're going to go over all those types of patches, by the way. JSON patch, merge patch, strategic merge patch has been since the beginning. With SSA, now we have what we call apply patch. Okay. We call that patch as well fully specified intent patch, FSI patch. Let's take a look about patching. I'm going to first go to the fundamental patching of Kubernetes before SSA. So first one is called strategic merge patch. What is the best use case for this patch? When you want to merge changes on the list and you have key. I'll give an example. It's very simple, and you bear with me because we're going to use the same example for every single patch. So what I do have here, it's a deployment with one container, Nginx, without any tag. and I have my ports setting up. What I want to do, I want to just add a tag on the image. So if I want to do using patch, strategic patch, I'm going to run this command, kubectl patch, the name of my object. For kinks is not required. Just to prove a point, I decided to set the name of the manager using the parameter -- field manager, and I put the name that I came up, patch SMP, and then -- type, the strategic, which is the type of the patch. If you look at the patch, okay, it's pretty much a JSON file. I'm just changing the image. I'm putting a tag on the image, and I need to specify the key because this is a list. It is a map, and then I need the key of that, which is nginx, the name of my container. Very well. I run this, and then I'm gonna inspect my object. I do a get deploy. I don't like you just give me the containers. Now I see my image. My image has changed. Now I have a tag 1.8, 1.28. Now let me look my managed fields. Now I do have an entry of the managed fields that my manager, the same name that I added on top, updated, and now this guy owns this particular field, and everything is done by the SSA. All the management of the manager field is done by SSA. So this is strategic merge patch, is the default for kubectl patch. So basically, you just specify what you want. The second type of patch is called merge patch. When are you gonna use merge patch? When you wanna replace the whole array, wholesale. So again, I have the same deployment, I reinstate my original deployment. Run the kubectl patch command. I specify the object. This time I changed my field manager. Instead of patch SMP, I put patch merge, and very critical, the type is merge. And it's pretty much the same patch as before. It's exactly same body as before. However, because this replaced the wholesale, I lost my configuration of the ports because this patch does not have it. So it kind of replaces it. So you got to be careful when you manage patches, right? If I do a kubectl show manage fields, again, I have a new entry with the manager that is specified up here, and the operation update. The last patch, old patch, if you will, I want to talk about is the JSON patch. It's very good for exactly changes, like you know what you're doing. I call it almost like a sniper patch. Again, my intent, I want just to change the image and add a tag. Then I'll invoke again kubectl patch deployment. I create a field manager. I set up a field manager called patch JSON. Again, this is optional, but I just did because I want it. And the format, very important. The format of this patch follows an RFC. It's not you don't see Kubernetes, but you have JSON paths, and then you have operations. So first here I'm testing that if the name is nginx, then I'll replace the value of the image. This is the path of the file, the path of the JSON pointer to the what I want. And again, SSA will create an entry for you on the managed fields. with the manager you just specify. So this is the patch since the beginning. Okay. Now, I'm going to talk about what SSA is bringing to the table when it comes to patch. That's what we call apply patch type. What is the best use case is declarative, and a server-side apply computes all the changes for you. So we have same usual suspect, and now I'm going to apply this patch. The first fundamental difference here, no more kubectl patch. It's kubectl apply. kubectl apply. And the moment that we pass -- server side, we are telling the server will handle the patch. I will hold the force conflicts after. I want you to pay attention to the body of this patch. Doesn't look like exactly a YAML file. It's not almost like a mini manifest because it's declarative. It's declarative. You specify, it's a FSI, fully specified intent. You specify what you want to change, and you throw over the wire to the API to manage. Now, the -- force conflict is the parameter that you're telling the API from now on, the field manager that I specify, in this case, I came up with this name called apply FSI. I will own this field. So I ran kubectl get deploy. I made sure my change got applied. I got my Nginx 1.28, and I didn't lose my other settings. And now let me look the show manage fields. The show manage fields I have now a new manager, apply FSI, the same name that I came up with here for the image field, and the operations apply. That's the major difference. Now is the operation apply, okay, instead of update. So what the advantage of all this? Now we have a way to declarative and idempotent by design, having the API, all this logic is on the API. We use kubectl apply -- server side instead of a kubectl patch. And part of this fully specified intent patch, we have the namespace, the kind, everything. It's almost like a mini manifest. And you specify the desire where we want to go. It's GitOps friendly. We're going to go over a couple of slides about how to set up GitOps. And we have multiple controller environments. It supports really big objects like CRDs with more than 262, 144 bytes. If you have really big objects, SSA is the only way to go. And SSA is establishing the foundation for more upcoming features. So apply-driven reconciliation, field level access control, in-place patching, the pod resizing, and conflict-aware automation, and who's gonna own that field. That's pretty much when you can delegate fields to other controllers. And we do see now who is changing the object, right? Before we only have the last applied annotation. Now you can go and see who is changing the object and each field. And one of the sub-products of this talk is a mindset, introducing a mindset that you might have it, but maybe it's not explicitly. How we delegate fields to controllers. Let's think about HPA for a sec. Okay, HPA horizontal pod outscaler. Do you care about spec replicas on your Git? Perhaps when you're about to create the object for the first time. You're using HPA. The HPA controller gonna take charge, right? Because replicas go up and down, up and down. What is on Git? It's no longer the reality. If you go to your object and do a kubectl get object show manage fields, you see the spec replicas is owned by HPA controller. And from now on, what is on Git? Why do we care when it comes to HPA? It's our policy. The minimum replicas, the maximum replicas, the target utilization, etc. What we are introducing here, we're inviting everyone to rethink, is a mindset change. What you want to control is the policy intent over the actual value. And how you do this with GitOps, example of Argo CD. Argo CD has a couple tunings. There's the ignore differences, where you specify managers that you can ignore, and you can specify JSON pointers as well. So basically, you're telling Argo, ignore differences on those fields because I don't control them anymore. But at the same time, SSA doesn't let you to give away the changes because you still have, you can have audit, you have all these goodies. So those settings you can do on application, for example. In this example, straight from Argo, you can just tell like any change of kube controller manager, I'm gonna ignore and I'm gonna have auto sync. On the same token, you can put spec replicas again because of the HPA. There is another setting too that you can tell Argo since the beginning of the synchronization using server-side apply equal true. It's not a default, but at Stormforge 3-4 months ago, we had so many CRDs and they're getting so big that we flipped the settings, and so far so good. We are happy now. We have multiple Argo plays with a SSA. For Flux, funny thing is Flux, I went to a bike ride with Andrew Martin, my good friend, and during the bike ride, he came up about the managed fields. I didn't come up with that. He said, oh, in managed fields, Flux is working. Like, I was wondering how Flux works. And it's funny you came up. Kudos for you because it's an obscure topic for a bike ride. And he gave me the settings, him and his team, that basically Flux, you make this annotation on the apply policy, you put if not present. Basically, it will create those objects with those settings, but once you have a control like cert manager, I think that's gonna take over certain fields, Flux will pretty much ignore. Final words about this and call to action. Use kubectl apply -- server side when possible. It's gonna you have much better results when you create objects and update. Bigger objects you want to be managed over SSA. It's part of Kubernetes life, multiple actors managing your YAML. Have a conversation with your vendors, your Kubernetes vendors. Engage them, test them, how sharp they are and how integrated they are with the ecosystem of server-side apply. For example, we Stormforge, I spent so much time leveraging SSA to manage resources. We do patch for a living, our patch, their FSI, etc., etc. We end up helping Argo rollout to support strategic merge patching for the next version. If you use Argo rollout, if you try to patch Argo rollout, you're not going to have good results. And for the next version, strategic merge patching will be fixed. And finally, on Git, concentrate on policy intent over the actual values. That's all I have for us to say. I try to be very simple and practical.
Thank you. Thank you very much for that, Rafa. It was eye-opening for me. I didn't know it was so complex. And we have 10 minutes, so I do have some questions.
Sure.
Spicy one as well. Hopefully.
Hopefully I'll be able to answer, because one thing that I didn't do a disclaimer. This is a very complicated topic.
I can see.
Very complicated. Very complicated. I had to go through many routes to kind of like squeeze this in a very practical and simple explanation.
On the complicated way, you know, one of the things that one of the idea at the beginning was like, you know, all my state is in Git. Git is the only thing I need to care about, right? And now, you know, we got to a stage, you know, we progressed, and I think as a community we moved sort of away from it, and you know, some pain points are coming out, and you just pointed at some of the pain points. And if I look also, you know, even the pod itself changed during the years. At the beginning was almost immutable. Now we have import, replace, you know, insights replace, and then the fields itself, ephemeral containers as well. It sounds like at the beginning, things were a little bit simpler, but as we progress, things are getting a little bit more flexible, and they can be changed quite a lot. So my questions to you at this point, is this becoming very hard to debug? Is it becoming more complex to understand why things have changed in my deployment, and what is the cause that is actually breaking things?
Yeah, well, that's a great question. It's getting more and more complicated because we have more and more features. I am from the era that scanning processes real time or patching was almost unthinkable, the same way we are doing today with Kubernetes, right? And there is a cost for these all features, which is getting the ecosystem more and more elaborate. My take on this, you have to increase observability to get traceability of changes. So managed fields is a great feature for this. And more and more, I like the paradigm of Git the policy. So the moment that let's say HPA again, I love this example because we are already using SSA since the beginning with HPA. Nobody, just works. The spec replicas on Git, what you care now is the min and max. So if it's varying widely, what you want to control is a policy. What is the target utilization? What is the min and max? And if it's still misbehaving, then you have to check the value. And that's where observability comes and audit. And now we do have, like you explained, the webhooks, the mutation webhooks, etc. And it's getting complicated, but at the same time, look what the capabilities we're getting nowadays. Is a trade-off.
I think, yeah, you're right. There's a trade-off between the two. I think in my mind is like, you know, let's have a look at, for example, the in-place pod resizing, which I guess you're using quite a lot, right? Yes. My sort of, the problem that I face, at least the problem I'm trying to solve is that sometimes you might have these controllers resizing one pod but not the other. and then in your observability, you see one pod misbehaving. But it turns out that not all pods in the same deployment now are the same.
Yeah.
And then you might say, oh, is this a problem with the application? Is this the problem with the application layer, right? So this complexity is taking us so far, and I'm wondering, it's not easy to reason about, and I'm wondering what is the, on the flip side, yeah, we got all this flexibility, but is any any upside for me to help debug all of it?
Well, there is an inflection point or a happy place, right?
Okay.
Where I've seen a couple submissions on KubeCon. For KubeCon North America was one of program committee for operational and performance. I saw a couple talks being submitted. I don't know if they made it the cut, but about over controlling over Git. Like,
Okay.
are we really doing the paranoia of Git, or letting that go? At the same time, you don't want to just have a controller without limits doing whatever they want. So there is a middle.
Okay.
When it comes to in-place pod resizing, where I came from Citigroup, my mindset on doing the StormForge is in-place pod resizing. It's almost UDP. You go and change if that sticks or not. You do not know. It's not guaranteed because you do not know if the node has enough capacity. And if you patch the workload, the deployment, stateful sets, etc., is the TCP. So the happy point, what I'm talking to customers there, in-place pod resizing is a great capability. It's almost like a hot fix in doing trading hours, doing production hours, moments that you really, if you got to trigger an alert that CPU throttling, your observability said, I'm throttling between 9 to 5. You can, if you have your strategic to your patching, you can trigger in-place pod patching, and that one can trigger after hours a patch on your deployment. That's where I'm coming from. It is complicated to come up with this strategy, perhaps it is, but if you have the tools, the observability, the controller to patch your resources when needed, based on event, based on policy, you can make it. I'm from the era that you have a bare metal or a VM. If you're losing capacity during the day, you're out of the water. Today we have tools.
Okay, I've got one last question, which sort of struck me when you presented this, and one of the things that really sort of opened my eye was like, it turns out that now every field inside a pod, inside an object, can be managed, can be owned by an entity, right, by a manager. And a part of me was a little bit scared because I can see people taking this very, very far, not just to the controller level, but also from a management. This team is only managing this field, this person is only managing that field. How far people can take this. So I just want to see, what is your vision on this? Where do you see, the bad things and the good things coming out of someone or a controller managing a specific field in a specification?
Well, you can always put bad actors to take over the entire, do a patch and force conflicts for the whole thing. But, it's much better having this mechanism concentrated on API.
Okay.
Then, imagine if it was before this, you could have like a cron tab running kubectl apply.
Yes.
With completely oblivious from the other human being calling. So now we are centralized. I'm not a big fan of the force conflict parameter.
Okay.
Because it feels like you're taking over and nobody else is.
Okay.
But that parameter signal who ultimately owns that little piece of the YAML. By design, I didn't tell when we can co-own fields because I think it's a little edge case. But now you can really delegate. You can tell Argo, you can tell the operator, now there is a controller. If this controller provides observability hooks, like for example, we install hundreds of thousands of patches a day in a given, in a cluster, right? So imagine this, we installing thousands of patches. For every patch, we do a hook, we can put on a queue and go to an SNS, an SQS, and then you hook up your change control system. This is a way that you can still delegate, give away, but you're not losing auditability. It takes time, it takes effort, yes, but you have to look what you get back, right? We save so much because the moment we patch real time, we save 40%, etc. We give exactly what they need. This is a problem that a human being cannot change. It cannot solve. It doesn't scale. So we are pretty much using what we got in terms of the Kubernetes ecosystem for our advantage.
Okay. Thank you, Rafa. I think that was like it was really nice. I learned quite a lot, and I want to thank you for that. I'm way more aware of server-side apply than before. That's for sure. Rafa, thank you very much for joining the stream. I really appreciate it. I'm sure the people listening or tuning in will do as well. Yes, that's it for today. Thank you very much, Rafa.
I appreciate the opportunity. Just want to give the plug. I have a couple talks coming to KubeCon.
Yes.
If you're in a maintainer summit, it's about disaster recovery with Rafael from TAG Operation Resilience. I'm from the TAG. We're going to have, during regular KubeCon, a panel, how we can make your clusters be resilient and operational. And we have a mascot now called as a tardigrade. So your clusters, be resilient as a tardigrade.
That sounds great. That sounds great.
And my book too. I have a book signing on booth 150. We're going to give away 100 books. CloudBoat is sponsoring. The list price of the book is $60. So come, I'll be signing. My co-author, Chad, unfortunately will not be there. We're thinking to have a flat Chad by my side.
Oh yeah, that would be amazing.
I don't think he knows this, but yeah. Well, if you see me around, just stop me and we chat, whatever we can. And I always want to learn from you, from Dan, from everyone listening, because Kubernetes, it's amazing. You never stop learning.
Thank you very much. It was lovely talking to you, Raf. I really enjoyed. Thank you very much for joining the stream. Bye.